Okay, hello everyone. Alright, so the next program in chapter 6 is Savings Account Class. Alright, so design a savings account class that stores the savings account's annual interest rate and balance. The class constructor should accept the amount of the savings account's starting balance. The class should also have methods for subtracting the amount of withdrawal, adding the amount of deposit, and adding the amount of monthly interest to the balance. The monthly interest rate is the annual interest rate divided by 12. To add the monthly interest to the balance, multiply the monthly interest rate by the balance, and add the result to the balance. Test the class in a program that calculates the balance of a savings account at the end of a period of time. It should ask the user for the annual interest rate, the starting balance, and the number of months that have passed since the account was established. A loop should then iterate once for every month, performing the following. So A, it's going to ask the user for the amounts deposited into the account during the month. Use the class method to add this amount to the account balance. Ask the user for the amount withdrawn from the account during the month. Use the class method to subtract this amount from the account balance. Use the class method to calculate the monthly interest. After the last iteration, the program should display the ending balance and the total amount of deposits, the total amount of withdrawals, and the total interest end. All right, so we are going to create a savings account class that's going to hold a starting balance and an annual interest rate. It's going to have some methods, some accesses, some mutators, and a constructor. At least one constructor. So let's go ahead and start. Let's create a public class. Let's create a savings account class. So I'm going to go ahead and define a public class, and I'll call it savings account. Just savings account with an S here. Okay, so it's public because I want it to be available to code outside of this class, meaning code outside of this class, any code different from this code that is outside of this class can access it. All right, so now let's go ahead and define the fields of this class. Let's see if the question, I'm sure the question mentioned it. Let's go through it and see what the fields are. So design a savings account class that stores the savings account annual interest rate and balance. So we know the fields are the annual interest rate and balance. So let's go ahead and define them. I'm going to go ahead and define a private field for the annual interest rate. Actually, since annual interest rate is going to be fixed, right? Since it's going to be fixed and it's a fixed number, right? I'm going to go ahead and define it as a final double, right? So I'm going to define a private final double, and I'm going to call it starting underscore balance. Okay. Oh wait. All right, so starting balance and I'm going to set it equal. Well, you know what? Let's not initialize it. Let's just define it now. And I'm just defining it as a capital because by convention, constants are defined as capitals. It's like good practice. All right, so it's a private field because I don't want to code outside of this class to be able to directly access this field. I don't want code outside of this class to be able to directly see the content of this class or even change it. Well, finals, you can't even change it, so it won't work. But that's the purpose of defining this as a private field, so that we hide this field so that no one can, or no code outside of this class can access a class or even try to change it. We want only methods or code in this class to be able to access them, right? In other words, I want code outside of this class to be able to use other means to access this field, instead of being able to directly access the fields. All right, so the next field I'm going to go ahead and define is also a private field. That's going to be our balance. So I'll define a private double. Well, I know that the balance can be a double, right? It can be 25.7, it can be just 25. So I'm going to go ahead and define a private double field. So private double, and I'm going to call it balance. Okay. All right, so now I'm done with the fields. Let's see what's next. The class should also have methods for subtracting the amount of a withdrawal, right? Adding the amount of a deposit, and adding the amount of monthly interest to the balance. All right, so now we're going to create, let's say, a withdrawal method, instance method. So let's go ahead and do that. Now it's going to be an instance method, okay, because it's going to directly work on the fields of this class. Any method that works directly on the fields of this class is, sorry about all of these. Okay, so any method that works directly on the fields of this class is an instance method, okay? Instance methods don't have the keyword static. Apart from that, they work just like any regular method, right? So for now, just know that instance methods don't have the keyword static, right? As we move on in the chapters, you'll understand it more. But then for now, just know that instance methods don't have the keyword static. So I'm going to go ahead and define a public method. Public because I want code outside of this class to be able to use these public methods to, for example, either let's say. So let's look at the function. So I want code outside of this class to be able to use these instance methods to affect the fields of this class. So in this case, to withdraw something from the account or to deposit something from the account, right? So let's see. The first thing I'm going to create is going to be a withdraw, let's see, method, right? So again, public instance methods don't have the keyword static. So public, let's see if it has a return type. All this method is going to do is let's see what it's going to do. The class should have a should have methods for subtracting the amount of withdrawal. Let's see. Okay, so we know this method is going to affect the balance field, right? So that's all. It's not going to really return anything. It's only subtracting something from the balance. So let's see what it's going to say over here. Let's see. All right, so the purpose of this withdrawal method is going to accept a value and then subtract it from the balance field. So I'm going to define a public instance method. Again, no static keyword, no return type. So I'm going to set a return type to void, and then the name of the method is going to be, I'm going to call it withdrawal, right? So I'm going to call this withdrawal. So public void withdrawal, and then this method is going to accept an argument. So I'm going to go ahead and define a parameter. And the parameter is going to be the amount, right? The amount can be a double. So I'm going to define it as a double. It can be either $25 or $25.2. So I'm going to define it as a double. And I'm going to call it amount. Or I'm just going to call it user amount so it's more specific. So user amount. And once the user has given us the amount, whoever calls this method, once they pass in this user amount, what we want to do is basically subtract this user amount from the balance. So balance, right? So balance is going to be equal to what's already stored in balance, right, minus the user amount. Once the user passes in the user amount value, we are subtracting it from the what's already stored in balance and storing the result back in balance. So if balance, let's say, has $2,000 and the user subtract $100, then we have to be over here. It's going to be 2,000 minus 100, which gives us 1,009. We are storing the 1,009 results back into balance. Now this statement can also be written in a shortcut version as balance minus equals user amount, which means I am subtracting user amount, okay, from balance, or what I'm subtracting from balance, okay, is user amount. You can think of it that way if it helps. All right, so the next method we are going to define is the deposit method, right? It's going to be very similar to this. All it's going to do is it's going to add the user amount to balance. So I'm going to call this deposit. So public void, not withdraw, but an deposit. So public void deposit Okay, it's not going to return anything. It's going to do is perform an action on the field. It's not going to really return anything. It's also going to receive a user amount. It doesn't matter if these names are the same. The scope of this variable is within this method, and the scope of this variable is within this method. These two don't see each other. They are considered two different variables because they are in two different methods. All right, so now that once we get the user amount, what we want to do is we want to add it to the balance. So again, you can write the shortcut version, balance plus equals user amount, which means I'm adding user amount, okay, to balance. All right, now I have those methods. Let's see what else we have to do. So the class should also have methods for subtracting the amount of withdrawal, adding the amount of deposit, and adding the amount of monthly interest to the balance. So now we have to create another method which is going to add the monthly interest to the balance. So let's see. So it tells you that the monthly interest rate is the annual interest rate divided by 12. Well, first of all, let's go ahead and start creating that instance method as well. So public void, it's not really going to return anything, so I'm setting a return type to void. And this method, let's go ahead and call it add monthly interest, add monthly interest. Okay. Then let's see if it's going to accept any arguments. All right, for now I don't think so. So we set a return type to void. I don't think so. If there's anything, we'll come and change it. But let's see what this method is going to do. This method, when you think about it, is going to find the monthly interest rate. Sorry, it's going to find the monthly interest and then add it to balance. So it tells you, gives you a hint over here. It says, well, and adding the amount of monthly interest to the balance. The monthly interest rate is the annual interest rate divided by 12, right? So we can break things down, or we can do it in one step. We can say that we can first figure out the monthly interest rate. So we can go ahead and create a variable here, call it, let's say, double. Well, I don't really want to do this, but we can do it in one step. Okay, we can do this in one step. Let's try to do this in one step, or let's say maybe two. So what we want to do is we want to find the monthly interest rate, which is going to be our starting. Oops, sorry. Wait. There's a big problem here. I don't know why I did this. I have the starting balance here, and then I have another balance here. Let's see. Design a savings account class that stores the savings account annual interest rate and balance. All right. So what I wanted to do, what I meant to do was save this as the interest rate and not the balance. Okay, and not the balance. That's a big mistake, and I'm sure some of you saw it. I'm sure some of you are confused. All right, let's just clear it up. This is not going to be the starting balance. This is going to be the annual interest rate. So sorry. Annual interest rate. All right, so the annual interest rate and then the starting balance. All right, because otherwise we have two starting balances. All right, so I don't want anyone to get confused. Just it skipped me for some reason. Okay, so now we have our annual interest rate, which is going to store our annual interest rate value, and our balance, which is going to store our balance. Okay, so now to calculate the monthly interest, we want to go ahead and divide the annual interest rate by 12. So it's going to be the annual interest rate by 12 here. So that's our monthly interest rate, right? And we want to find the monthly interest rate of the balance. Okay, so we can read off as the multiplication sign. So if I basically do annual interest rate divided by 2, which is the monthly interest rate of the balance, I'm basically I'm assuming the annual interest rate is 12%. If I divide that by 12, okay, if I divide that by 12, each of them is going to be the monthly interest rate, right? And when I multiply that by the balance, I'm finding the monthly interest rate of the balance and not the annual interest rate. So this is basically finding the monthly interest rate of the balance. And once we are done, we want to go ahead and add it to the balance. We want to add this result this value or this amount to the balance. So we can use the same idea here. We can say balance is equal to what's already stored in balance plus the results of this. I'm going to even go ahead and put parentheses around the whole thing just to keep the order of operations here. So calculate this first, multiply this, evaluate the whole thing, and add it to what's already stored in balance. Just like we did here, you can write this as a shortcut version and say balance plus equals this result. All right, so if we've done it in one step, which is good. All right. So it tells you to add the monthly interest to the balance, multiply the monthly interest rate by. So let's see, it tells you over here the monthly interest rate. It gives you a hint that the monthly interest rate is the annual interest rate divided by 12, which we've done here. To add the monthly interest rate to the balance, multiply the monthly interest rate by the balance. So this is the monthly interest rate by the balance. And add the result to the balance. And we've added the result to balance here. Test the class in a program that calculates the balance of the savings account at the end of a period of time. All right, so before we go ahead and test the class, let's go ahead and create a constructor. And the constructor is basically what's going to be used to create an object from this class. Now the constructor is also just like a method. It doesn't have the keyword static. It doesn't have a return type because we do not call the constructor ourselves. The constructor is called automatically when you try to create an object from this class. So because of that, because we do not call it ourselves, it can't return anything. And because it can't return anything, we don't specify a return type. So it's just like a regular method, but no static keyword, no return type. So I'm going to go ahead and call public, and then just the name of the constructor. Now the name of the constructor has to be the same as the name of the class. So it's going to be public. Because the class is called savings account, I'm going to call this public savings account. Apart from that, it's just like a regular method. And public savings account, let's see how it told us to, or basically what it said about the constructor. Let's see. It says the class constructor should accept the amount of the savings account starting balance. So that's what it's going to accept as an argument. So let's go ahead and define that as a parameter. So it's going to accept the amount of the savings account starting balance. We know the balance can be a double, let's say 25.2. So let's define that as a double. So define, it's not supposed to be defined. It's supposed to be double, double starting balance. And then let's see if that's all. The class constructor should accept the amount of the savings account starting balance. The class should also have methods for subtracting. Okay, so it seems the only thing we are setting when someone tries to create an object from this class is the starting balance. So if the person gives us a starting balance, what we want to do is we want to set the balance field to be equal to the starting balance. But we also need a value for the annual interest rates, right? So let's set the annual interest rate to be equal to 0 for now. 0 for now, until the person sets the annual interest rate, because I believe the question says over here, down here, it says, where is it? Test the class in a program that calculates the balance of a savings account at the end of a period of time. It should ask the user for the annual interest rate. So we know we're going to be asking the user for the annual interest rate. So when the user gives us the annual interest rate, we are going to set the annual interest rate field of that particular object. Because of that, since our constructor is only accepting the starting balance, we need a mutator to set to set the value of the annual interest rate. So we need a setter, okay, or a mutator to set the value of the annual interest rate. So a mutator or a setter is also going to be an instance method, just like these instance methods. So let's go ahead and create it. I like to keep my constructor as the last thing in the class, so I'll leave it as the last thing, and go ahead and create a setter for the annual interest rate. So public void, because we are not really returning anything. All we are doing is setting the value of the annual interest rate field. So public void set annual, I'm going to call it set annual interest rate. And once we are setting the annual interest rate, we need the value that you want to set the annual interest rate to. We need a new value you want to set the old value to, basically the new value you want to replace, that's going to replace the old value of the annual interest rate. When an object is created, the annual interest rate is going to by default have an interest rate of 0. So we will need a new value. So I'm going to go ahead and define a parameter for the new annual interest rate. So the annual interest rate also can be a double, and that's why we define it here as a double. It can be 2.6% or 8.5. So in that case, let's go ahead and define it as a double here and call it annual. We can even say new rate. And once the person provides the new rate, when they call this or when they try to create an object from this class, we want to go ahead and set the annual interest rate field here. Hold on a second. We want to go ahead and set the annual interest rate field here to be equal to the new rate. Now if we have problems, we'll fix it, but for now, because with doubles you can't really change the values of it, right? You can't really change it, because if you set it to 0, then over here you are trying to change it. That's a problem. So I know you're going to have a problem. So if that's the case, then what we should do is we can in the constructor field we can go ahead and add another parameter for the annual interest rate so that it's set the very first time. If not, then let's change this from a final to a regular double, right? And change this to small letters, annual interest rate, to make it flexible. So everywhere we have annual interest rates, let's just replace it with this. And then over here, it's going to be annual interest rate. It's going to be equal to new rate. All right. So now we're good. And over here, we want to set annual interest rate to 0. Okay. So we know that the user is going to provide the annual interest rate. So let's see. It should ask the user for the annual interest rate. Okay. It's also going to ask the user for the starting balance. So we are fine with that. The starting balance, at least we know that we can set it in the constructor. We can also create a mutator for the starting balance, but we don't really have to, because you can create that if you want, but we are going to use a constructor to set the starting balance. Okay, it's also going to ask for the number of months that have passed since the account was established. For that, we'll deal with that in the main program. A loop should then iterate once for every month, performing the following. It's going to ask the user for the amounts deposited into the account during the month, and it's going to use the class method to add this amount to the account balance. So it's going to use the deposit method to add that amount to the account balance. And then it's going to ask the user for the amount withdrawn from the account during the month, using the class method to subtract this amount from the account balance. It's going to use the withdraw method to subtract that amount from the balance. And then it should use the class method to calculate the monthly interest rate. After the last iteration, the program should then display the ending balance, the total amount of deposits, the total amount of withdrawals, and the total interest rate. So where we are calculating the annual interest rate, we call it add monthly interest, right? We calculate the monthly interest, and then we are adding it to the balance. We just said add, the program said calculate, but we called it add. All right, so let's now shift to the program that is going to test this class. This is not a complete program yet, it's just a class. So we need to create a program that's going to test this class. Let's go ahead and save this. All right, so the previous program was a game of 2 into 1. So I'm going to go to chapter 6, create a new folder in chapter 6, call it savings account, and then save this here as SavingsAccount.class. Let's see if you have any errors. Okay, so we don't have any errors, so that's fine.